A function is a mapping from one collection of objects to another. In pre-calculus courses, this is usually done as functions that take real numbers as their input and return real numbers as their output. For example, f of x equals x squared is a function. It maps the number 2 to the number 4 and the number -1 to the number +1. We can represent this using an arrow diagram. An arrow diagram is a tool to help conceptualize what's happening with a function. The region on the left represents the domain, which is the set of valid input values for the function. Notice that the displayed values are not comprehensive. We are simply using this as a conceptual tool. The region on the right is the codomain, which is the set of possible output values. What makes this a function is that every value in the domain maps to exactly one value in the codomain. If any of the values in the domain have 2 arrows leaving it, the resulting diagram would not represent a function. Notice that not every output value gets mapped to by this function. For example, there is no input value that can ever make x squared equal to -1. The range of a function is the collection of values in the codomain that are mapped to by some value in the domain. The inverse attempts to ask the question, given an output value, what input could it have come from? For example, to find the inverse of 1 under this mapping, we would trace these arrows backwards to see that both plus and minus 1 map to 1. This is the essence of the inverse question. From this, we see that the inverse is the mapping you get when you swap the domain and codomain and turn all the arrows around. Notice that the inverse is not necessarily a function because some numbers may have 2 or more arrows leaving it. When this happens, we sometimes have to make a decision to restrict our range in order to eliminate the extra arrows. This is what happens with the square root function. When we take the square root of a number, we always choose the non-negative value. This is why we explicitly have to include a plus or minus when we solve equations. We may also need to remove values that were never mapped to in the first place. For example, we would eliminate -1 from the domain of the inverse because there are no arrows leaving it at all. This is basically what we mean when we say we can't take the square root of a negative number. When we look at the graph of a function, the variable x represents the input, and the variable y represents the output. The act of swapping the input and output is the same as swapping the x and the y variables. Graphically, this is reflecting across the line y equals x. For example, here's the graph of the function f of x equals x squared. When we look at the inverse, we get this picture. In order to make this into a function, we restrict the inverse to just the non-negative values. And this is how we get the graph of the square root function. In the next video, we will see how these concepts apply to trigonometric functions.